Let's have a discussion on inductance of single phase two wire line. This is also an important topic. So here I am considering a single phase two wire system in which one conductor is used a return path. Okay, first conductor, second conductor. This is used as a return path. That is nothing but neutral. That is goes to the earth. Okay. For conductor one, there are two fluxes. Already you studied internal flux and one more is external flux. For the conductor one, there are two fluxes, internal flux, external flux. It has the radius R1, carries a current of I1 here, and the conductor 2 of radius R2 carries a current I2 here. But here both currents in the conductors I1 and I2 are in opposite direction. Therefore, I1 is equal to minus I2 or I1 plus I2 is equal to 0. Okay. The conductor 1 is placed at a distance d from the conductor 2. So the flux linkage takes place in both the conductors due to their electromagnetic effect occurs between these two conductors, so that the total flux linkage in the conductor 1 is equal to the flux linkage by itself, and one more is the flux linkage on the conductor 1 due to the conductor 2. Okay, the flux linkage in a conductor 1 is two flux, one is internal plus one more is external flux. Internal flux is due to the self current of the conductor 1, and external flux, that is flux linkage on the conductor 1 due to the conductor 2, that is current flowing through the conductor 2. It gives the external flux for the conductor 1. Similarly, the flux linkage in the conductor 2 or conductor B, the is equal to flux linkage by self current of the conductor 2 plus flux linkage on the conductor 2 due to the current through the conductor 1. Okay. Therefore, I1 plus I2 is equal to 0 because I1 is equal to minus I2. Already I said, right? So we have to see the total flux of the conductor 1 and also total flux of the conductor 2. Okay. See, if find the total flux of the conductor 1. Similarly, we can write for the conductor 2. Therefore, total inductance of these two fluxes gives here L1, here is L2. Total flux is L1 plus L2. So, total inductance is L1 plus L2. Okay. See here, these two conductors are placed at a distance here, capital D. It has a radius R1, it has a radius R2. Okay. While calculating the flux of the conductor 1 due to the conductor 2, we have to take the distance D minus R1. Similarly, external flux of the conductor 2 due to the conductor 1, you can refer the distance is D minus R2. Okay. That is, we are not calculating from the center, that is for the conductor from the center to this conductor. So we are taking D minus R2, here D minus R1, right? See here this figure, it gives the external flux around the conductors in two wire single phase line. Two conductors, here they are referred A and B conductor, carries the current IA and IB. Distance between them is capital D. This is the figure. Internal flux, here internal flux for the second conductor due to the external flux each other. Okay, distance between them is capital D. See, we will calculate the flux of the conductor 1. Similarly, we go for the second conductor. Okay, flux in the conductor 1, phi 1 is equal to flux internal plus external flux. So already we calculated internal flux is mu I divided by 2 pi 8 pi plus mu I divided by 2 pi ln of external flux is what? Ln of d2 by r1. d2 by r means capital D by r, nothing but capital D is what? Distance external, whatever we have considered the flux, from that distance we have to take, divided by radius of the conductor, right? D by r, right? So here D is what? D minus R2. Why you are taking D minus R2 here? See from the see here the figure from the see here D minus R1 why it is. See distance of the conductor 1 from the conductor 2. Why? It is the external flux due to the conductor 2 on the conductor 1. So distance of the conductor 1 to the conductor 2 is D minus R1. We are not taking radius of the conductor 1 because this is already included ln of D divided by R1, that is radius of the conductor. Here D means what? It is from the second conductor to the first conductor. So distance between them is D minus R1 divided by R1. Similarly here also we have to take D minus R2 divided by R2, external flux, right? So external flux getting D divided by R means D whatever external flux distance divided by radius of the conductor. Okay. So here compared to the distance between them, radius is very small. Radius of the conductor is very small, negligible. We have to neglect the radius of the conductor. So here I am taking D minus, instead of D minus R1 I am to take, or D minus R2 I have to take D divided by R1. Here substitute mu value mu naught into R1, sorry mu naught mu R is equal to 1. Total inductance, okay, this is total flux, then total inductance means what? Flux divided by current. Current can get cancelled here from this figure. Take common here, 2 pi outside, inside is 1 by 4 ln of D by R1. Okay, here ln term is there, make it this term also log term, take it ln of e raised to 1 by 4, constant term e raised to 1 by 4. So ln plus ln means ln of this into this, right? Therefore ln of D divided by R1 into e raised to 1 by 4. Here I am taking e raised to 1 by 4 in the denominator side. Therefore I am taking here minus. Getting plus means ln of this multiply this, right? E raised to 1 by 4 into D divided by R1. Here take it e raised to 1 by 4 denominator side, that is I am taking the minus. It comes to the numerator side, e raised to 1 by 4. Nothing has changed here. Same equation just modified. Therefore inductance is equal to 2 into 10 to the power minus 7 ln of D divided by R1 e raised to minus 1 by 4. I am taking this as a R1 dash. See here R1 dash is equal to the substitute here. E raised to minus 1 by 4 value is 0.7788 R1. Okay, this is called geometric mean radius, GMR of the conductor. The detailed study of this GMR will discuss in the next topic. Okay, here for this second conductor you have to take the L2, total inductance of the second conductor. For the loop you have to take 2 times L1. Okay, next L2 similarly divided by R2 dash. Next total L is equal to L1 plus L2. Here root 1 R1 dash into R2 dash. I am taking this is a common as a R dash. Okay. Therefore, we will take D divided by R dash, where D is the what? Distance between the conductor. R dash is the what? Radius of the conductor. This is radius means itself distance. This is the what? Distance between two. Therefore, this capital D we have taken. We have to see that this is a GMD, geometric mean distance. See here, D means GMD, that is denoted by DM. Geometric mean distance means distance between two conductors. R means the distance of itself, means radius of itself, conductor itself only. So that is GMR. This is referred as a GMR, geometric mean radius. That is radius of the conductor. This is distance between the two conductors, GMD divided by GMR, or DM divided by DS. Okay, this is the what derivation of this.